Hello everyone, welcome to my channel. William Talk Physics Easy.
Today, we are going to discuss on the relationship between V, I and R. So there are three simple basic equations, which is V equal to IR, V is the voltage, and then the second equation is I, the currents, which is a measure of rate of the charge flow. Then the third equation is R equal to rho times length over the areas. So from these three equations, the first equation states that V is directly proportional to our R. Then the third equation shows that R is directly proportional to the length. So we actually can use the relationship to form an equations like this. V1 over R1 equal to V2 over R2. When there is comparison between two situations, given information of V1, R1 and R2, the questions wants us to find the V2, so we can use the comparisons. Same goes to the R directly proportional to the L relationship. So let us see the basic knowledge to compare series circuit and parallel circuit. First, the I total for the series circuit always constant, which means I1 equal to I2 and then equal to I3. Then for the V total, V1 plus V2 plus V3 equal to the V total. Subsequently, the I effective is equal to R1 plus R2 then plus R3. Then for parallel circuits, the I total is equal to I1 plus I2 plus I3. Then the V total for the parallel circuit is always constant, which means V1 equal to V2 and then equal to V3. Then the R effective of the parallel circuits is 1 over R effective equal to 1 over R1 plus 1 over R2 then plus 1 over R3. So how do we identify the parallel circuits? So we can see when there is presence of the junctions means the circuit is in parallel. Alright. The typical question asks us calculate V, I and R using the relationship in both circuits. So the method to calculate the R effective in a complicated circuit is analyze flow of current directions. So let us see a sample questions. So here is a complicated circuit. How are we going to find the R effective? First, analyze the flow of current directions. So let's say the current start from the A flows until reach B. So how will it pass or how will it flow? So for sure it will pass first resistor like this, then they meet a junctions. So you are going to split to here, split to here, split to here, split to here. So we step by step analyze it. So we see for this flow of the first flow of the currents, it flows and flow across the resistor 2, then subsequently flow across the resistor 3. So means that the R2 and the R3 is series. So to find the R for 2, 3, we're using the series formulas, which is R23 equal to R2 plus R3, which means 3 plus 2 equal to 5 ohm. Then, since the current passed through 2, 3 and 4 is in parallel, see the first flow, the resistor 2 and 3 is the same, then the current flow through the resistor 4 is different. So if difference means they are arranged in parallel. So how we going to combine the R2, R3 and R4? So by using, just now we already combined the R2, 3 which is in series. Then now we combine R2, 3, 4 in parallel by using the resistance formula in parallel circuits, which means 1 over R234 equal to 1 over R23 plus 1 over R4. Then we'll get 11 over 30. Then the R234 is 2.727 ohm. Then we already combined the resistor 2, 3 and 4. Now it became like, we assume like this one is already combined. This is our R234. So for R234, the flow of the currents across the R234 and the R5 is same. So we can combine the R234s and the R5 using the series relationship, which means that R2345 is equal to R234 plus R5. Then we get our R2345 is 9.727 ohm. So now we already combine R2, R3, R4 and R5. So we assume like this is the new R2345. So R2345 and R6 and the R7s is arranged in parallel. So using the parallel formulas, we can find the R23456 equal to 2.6 ohm. Then finally, we already combine the R2, R3, R4, R5, R6 and R7 into ones, which is R234567. So the R1s and R234567 now is arranged in series. So the R effective is R1 plus R234567. We will get the R effective, which is the R total, and the final answer is 11.6 ohm. Is that easy to understand? I sure it's easy. So another questions. If the question given I total is equal to 2 amperes, find the VAB, the I2345, the I4 and the V23. It seems complicated, but if you use the relationship to relate with the questions, it will become very easy. So how are we going to find VAB? Actually, VAB also is equal to V total. So by using the formula V equal to IR, I total times R effective, we will get the V total. And the I total given is 2 ampere, and the R effective which we find just now is 11.6 ohm. So we will get the VAB, which is the V total, is in 23.2 watts. Then to find I2345, we must step by step to do it. So first we find the V for 23456 by using the V equal to IR. The I234567 is also equal to I1 and also equal to I total, since it is arranged in series. So for series circuits, the I always constant, so equal to 2 ampere. So we use 2 ampere time with the resistor 234567 with the resistance 2.6 ohm. So we get the voltage for 234567 equal to 5.2 watts. Then the voltage for the V234567 is also equal to V2345 equal to the V6 and subsequently equal to V7, which is the value 5.2 watts, since they were arranged in parallel and the voltage for parallel is always constant. So the voltage for V2345 is equal to 5.2. Then by using the V equal to IR, we can find the I2345, which is 0.535 ampere. Then for I2345 is same to I234 and same to the I5. Since the resistor 234 and the resistor 5 is arranged in series, so the I is constant. So the V234 is 1.459 watts. Then after we find the V234, we can find the I4 and the V23. Since the V234 is equal to the V23 and equal to V4 with the value 1.459 watts. Since what the resistor for resistor 23 and resistor 4 is arranged in parallel, so the voltage is constant. So we use the formula V4 equal to I4 times R4. Then we substitute the R4 value and the V4 value. We will get the I4 is 0.243 ampere. Subsequently, to find the IR3, we substitute the value of V23 and the R23, and we will get I23 with the value 0.292 ampere. Is that simple? Before we end this video, I'll give you a sample questions. So first we analyze the resistor is arranged in which circuits. For sure, the 10 ohm resistor and the 20 ohm resistor is arranged in parallel since they are present of junctions. Then after we combine both resistor, the 15 ohm resistor is arranged in series with the combined resistor. So we can use the relationship like just now I taught to find the I effective. Subsequently, we can find the potential difference across the each resistor and the reading of emitter 1 and the emitter 2. Alright, it's the end of this video.
Don't forget to hit the like button and share this video to your friends. Also, subscribe to my channels. Thank you everyone. I will see you in the next video. Bye.